Hi, everyone. My name is Brad Levin, and I'm the General Manager in North America for Visage Imaging. Welcome to our presentation, Next Stop Cloud 9, your ideal PACS platform. Today, we have a number of great speakers to share some outstanding cloud content with you. We've got Sean Lambright, the Global Head of Sales for Visage Imaging. We've got Bobby Rowe, the Director, Solutions Architecture and Customer Experience from Visage. And we also have Arie Meir from Google. So from an overview perspective, we're going to talk about cloud PACS, and we're going to start with the current situation with legacy PACS, which has predominantly been an on-premise implementation. And we'll talk about some of the stumbling blocks that have limited the success of legacy PACS, especially considering today's volume of data and performance expectations from end users. We'll talk about how local PACS is on the demise because of some of those challenges, and also what are the factors that have led to the rise of the cloud and has drawn so much interest in cloud-based implementations. We'll talk about the Google Cloud Platform and the attributes of the platform, particularly from an interoperability perspective that make it extremely well suited for cloud-based PACS. And then we'll talk about the ideal PACS platform for the cloud and how so many organizations are interested in moving their on-prem implementations to cloud-based deployments. With that, I'm going to turn it over to Bobby Rowe to talk a little bit about some of the challenges with legacy PACS. Bobby?
Thanks, Brad. Hi, everyone. And what I'd like to do is remind everyone of how we got to where we are and what we refer to as legacy PACS, which is all those different PACS environments that are out there that largely were designed in the early to mid 1990s and largely haven't been updated in their core underlying architecture since then. So some of the things that are a part of those legacy PACS environments are many different servers trying to compensate for the lower performance architecture that were built into those different systems back in the 90s and maybe even early 2000s that didn't take full advantage of the capabilities of the systems that were available at that time. Of course, that leads to what we call boxes and wires, a lot of different systems that are involved to try to overcome those deficiencies in the architectures. It leads to multiple points of failure, leads to more opportunity for things to go wrong or for things to get out of sync with each other, often leading to downtime of either unscheduled or longer downtimes, even for scheduled downtime events, so that there's enough opportunity to be able to do updates or hardware swaps or whatever might need to happen from an ongoing routine maintenance perspective, not to mention those unscheduled events. Oftentimes those older systems used what we refer to as compress and send architecture. So basically collecting everything into a single bucket, compressing that down, and then sending it across the wire to deliver it as efficiently as was thought possible at the time, and then decompress it on the other side of that connection into a system locally. However, in today's architecture and with today's medical images, where the size of the images is growing exponentially, where we see things like high-resolution digital breast tomosynthesis studies that are even on disk over 2 gigabytes and decompressed for viewing purposes, sometimes as much as 10 gigabytes worth of data in a single exam, where people are trying to do remote reading and trying to deliver even over really high-speed cable modem connections, that amount of data in a compress and send model, it takes a longer period of time than is practical from a professional perspective for a medical imaging experts, radiologists, and other users, consumers of that information. And oftentimes those systems were designed around two-dimensional imaging. So looking at the original axial slices, for example, on a CT, and if they wanted to see any kind of reformats, those had to be done either at the modality or on a post-processing workstation, something that does advanced visualization, which then adds additional time to the whole process of making those images available for the diagnostic users who need to see them oftentimes in an emergent situation. Next slide. As we talked about, not only are those solutions that are legacy in architecture and design hardware intensive, that leads to a significant upfront capital expenditure and oftentimes leads to limitations and interactions between all those different components that effectively maximizes their throughput capacity at something that is lower than what is effective and able to handle the full volume of data for some of the larger customers that are out there. Even some of the smaller customers, frankly, encounter performance issues because they oftentimes were designed around lower performance systems to start with. Oftentimes those systems are now well past their useful lifespan. They're sometimes still running operating systems from the early 2000s. So we have often heard of customers that are running systems that are still running Windows 2000 or 2008, as opposed to more current and modern architecture operating systems with all of the vulnerabilities addressed in those newer ones. Scalability in those older systems was something that was often attempted by adding more boxes and wires. Rather than fixing the underlying architecture so that it could handle more scale naturally and even on smaller hardware environments. Dealing with new modalities oftentimes has posed challenges. Some of the earlier implementers of PACS oftentimes chose architectures that had fixed types of modalities as their capabilities and didn't use an extensible DICOM toolkit that allowed them to add on additional modalities effectively and efficiently over time and do that with minimal or no downtime. All of that put together often also led to very long or complex implementation processes. We've certainly encountered customers where with their prior systems, their implementation were measured in multiple years rather than in multiple weeks. And those obviously stretch out the time that you see the return on your investment. If it takes 2 years to do an implementation and you're on a 5-year contract, for example, you're already 40% of the way through your contract before you've really even started to realize the full ROI that you thought you were going to get with that system. Next slide. So one of the things that's become very interesting and a high priority lately is security. A recent article in ProPublica talked about this, talking about how there are millions of medical images for Americans that are available openly on the internet because of a lot of those legacy systems not effectively addressing the security needs around those. Whether it be for antivirus, anti-malware, various different firewall configurations, other security approaches. Oftentimes those were simply not addressed because a lot of these systems were designed in the infancy of the internet and were not effectively patched to keep up with the more modern network architecture that almost always has some level of internet connectivity, if nothing else for remote support by vendor personnel or even staff personnel at a facility. All of those legacy systems tend to run older operating systems, older databases. If they are browser-based, they tend to rely on older browsers, oftentimes not even supporting newer browsers or newer web delivery or rendering technologies. And often that leads to interoperability challenges, not just the ability for the core PACS itself to be used on a current architecture operating system and browser or other tools, but oftentimes limiting the ability to use newer versions of other ancillary tools, such as those post-processing workstations I mentioned earlier, simply because of the gap in support for different browsers and having to stay in an older architecture because of one of the components of that larger infrastructure not supporting a newer browser. Next. So all of this leads us to the probably somewhat controversial statement that on-premise PACS is dead. And we certainly don't think it's completely dead yet. We think we're headed that direction. Certainly the attempt for a lot of larger customers and more savvy customers to start to implement their systems in the cloud has become fairly common over the last year or two. However, if you're trying to just lift and shift those legacy architecture systems and put them into a cloud-based environment, then you run into challenges related to those underlying architectures and having to move massive amounts of data. So oftentimes healthcare as a whole industry lags behind those modern capabilities, and certainly PACS is a prime example of that. However, things are changing as we're all seeing. The enterprise health record or electronic health record is often now shifting into cloud-based delivery. We're seeing our desktop applications shift into cloud-based delivery with everything from all the different Google Docs to Microsoft Office to various music delivery platforms and entertainment delivery platforms. Certainly during the times that we've been traveling, all of our travel generally is managed with cloud-based systems. So that's where we think things are headed. Next slide. Okay. So why aren't we there already? To put it simply, the systems that are legacy designed and architected are not optimized to be deployed in a cloud-based environment. They simply require too much processing power, too much network transfer. They still require delivering typically the entire data set to the local workstation, which leads to delivery challenges actually for any kind of remote reading, not even just in the cloud infrastructure. The whole scalability challenge doesn't apply as effectively to those legacy architectures because as you add more and more servers, you're increasing the number of communication lines between all of those and the challenges in keeping everything in synchronization, not to mention the ongoing maintenance challenges of keeping all of that up to date. You oftentimes end up with performance limitations and the system administration challenges that come along with even just something as simple as looking through a log file to see what really happened. You oftentimes end up having to look through dozens of servers' logs to find a single event because of that attempt of expanding scalability by increasing the number of boxes and wires. And often that means that it's just been cosmetic upgrades or enhancements in the entire system, which of course leads to challenges throughout the entire process for everyone. So we're here to talk about how we can shift all of that over into the cloud. And what I'd like to first do is hand the presentation off to Arie Meir from Google, who's going to talk about some of the capabilities that they're bringing to the healthcare industry. Arie, you'd like to take it over?
Thank you, Bobby. So to introduce myself, my name is Arie. I lead a product development team within a group called Google Cloud. And my team is focusing on developing cloud solutions for the healthcare industry. And today I want to share with you three things. And number one, what are some of the challenges we are hearing about when we are talking to healthcare providers? Number two is how we approach innovation in the healthcare space and how we're thinking about our product roadmap and solution roadmap. And number three is how we work with partners, specifically how we work with Visage in order to innovate in the space of medical imaging. So maybe starting from number one, I want to talk a little bit about some of the challenges that we hear from customers. And I broke it down in this slide into short-term, mid-term, and long-term. And I also highlighted some of the things that have been affected by the pandemic currently to show some of the shift that we've observed in the last 3 months approximately. So in the short term, and I think that my colleagues have mentioned this before, security is definitely top of mind. As customers are thinking about moving their data to the cloud, they want to understand what does it mean in terms of security implications, like what does it mean in terms of compliance with different security regulations. And they want to have a robust set of tools that helps them implement their organizational policy and make sure they are compliant with whatever legal framework that they are operating with. As a global company, we obviously have to think about different markets we operate in, and we work very closely with the relevant authorities in the markets that we work in order to help our customers meet their requirements around security, around compliance, around privacy. And the second piece I want to mention here is storage management, which kind of ties to the connection of, to the point that Bobby was mentioning around on-prem PACS is dead. So we know that every year there is newer devices, newer CT scanners, newer MR scanners that produce more and more slices with higher and higher resolution. And with the advent of AI, there is this desire to extract value from that data. But at the same time, storing that data effectively has been a challenge. Many of the providers have local requirements, local regulation require them, local or regional, sometimes national requirements to store the data that they collect on patients for a certain amount of time, at least 5 to 7 years, sometimes longer, for example, for pediatric patients. So we're seeing this kind of combination of desires. On the one side, I want to meet my short-term regulatory obligations and store the data on my patients. On the other hand, I want to be able to take advantage of this large-scale analytics and AI. And this kind of ties down to how do I store all this new data that is only accelerating effectively. The last piece in the short-term challenges, which has been kind of heightened by COVID-19 pandemic, is the reduction on CapEx expenditures. So as it is natural during time of uncertainty, individuals as well as organizations are trying to manage their expenses and trying to postpone capital expenditure decisions. And this is where any kind of system solutions that require a large upfront in investments might get a longer pause, while solutions that are pay-as-you-go, that are more SaaS-y in their nature, tend to be more palatable these days. So with this, I want to shift to the second section here in the kind of midterm challenges. So in this context, the telehealth story is something that has been definitely brought to the forefront by the COVID-19 pandemic. Essentially, hospitals realizing that they need to be able to provide at least some level of service and ideally close to their day-to-day level of service in a case of an emergency situation like this pandemic. And this is where in the context of medical imaging, of course, this boils down to teleradiology. And as hospitals are trying to optimize their business around their core competency, many of them are thinking about outsourcing their radiology services. And the natural question becomes then, how do you manage effectively the handoffs, and how do you manage the data integration, and how do you collect all the pieces of system you need to have in place, and how do you stitch it together? The other piece in this context, the other challenge is collaboration, right? So for example, for scenarios like tumor board, where you have not only radiologists, but sometimes a pathologist, a surgeon, nurses from various specialties. How do you bring all these people together? How do you enable researchers to collaborate, which dovetails to the third piece here. The third point is enabling research. So oftentimes, especially in the context of large medical centers, you have clinical arm and you have the academic research arm. And the clinical arm sees patients and generates data. The researchers want to run new studies on this data, publish new results, develop new tools. How do you enable doing that effectively while meeting all your regulatory requirements, but also using new tools, new technologies like cloud, like AI, as a competitive advantage to attract the best talent you can, because researchers go where there is money, data, and tools. or how do you offer your researchers the best tools, the best data, and the best fund access that you can. And the last piece here is the long term. So the idea here is many of the providers that we are talking to want to participate in the AI economy, right? Artificial intelligence has been the kind of the buzzword, for lack of a better word, of this space for a while. I think that we've been learning more and more about what artificial intelligence can and cannot do in the space. I think there's a lot of optimism around using artificial intelligence to optimize mundane operations and help the radiologists focus on where they can add value the most. For example, optimizing things like hanging protocols, triaging patients, identifying inconsistencies within the study or sometimes between the study and the reports. These are just some practical examples that we see customers developing solutions around. But at the same time, there is this bigger desire to develop AI algorithms that provide clinical value. There is this desire to consume AI algorithms that were developed by someone else. So anyone you talk to about AI, sooner or later, the topic of AI marketplace would come up. And then there is this nature, the delicate topic of how do you, as a healthcare provider, how do I enable monetization of data and generate additional revenue stream for my hospital, at the same time maintaining the privacy and the confidentiality and all my promises, guarantees to my customers, my patients, while satisfying all the required consent requirements. So these are the questions that we hear top of mind from providers. And then the last piece in this context is this precision medicine, which is like an umbrella term for tailoring therapies, diagnostics, or any kind of prescriptive recommendations to patients based on their own individual profiles. And this can include multiple sources of data about the patient, right? Like their genetic makeup, and their past medical imaging studies, their clinical data, their hereditary data, and so on. So this, hopefully this kind of sets the stage on what have we been hearing consistently from customers in the healthcare provider space. One thing I'll kind of summarize here is that COVID-19 has really shortened the time horizon, and for the, at least in the short term, kind of reduced the risk appetite, and we see customers, partners are more focused short to medium term, which is natural given the amount of uncertainty. And in the next slide, I want to share with you a little bit how we thinking about the space and how we have been organizing our product and solution development roadmap. So if I may move to next slide, please. So this is a dense slide, so I want to unpack it a little bit for you, and I want to bring your attention here to a few pieces, and they're marked here 1, 2, and 3. But maybe before I dive and talk about these 1, 2, and 3 pieces, I want to talk about like what does the slide represent. So you know how any complex system, it might be useful to think about in terms of layers and how different layers address different set of challenges, and the layers kind of build on top of each other. So in this very fashion, so some of the more technical folks might be familiar with the 7 layers of OSI model in networking. So in a similar fashion, this model kind of tries to capture what we have done in the healthcare space. So the first layer, essentially the data governance and infrastructure. So these are kind of the 2 boxes on the bottom here. They represent the basic building blocks on top of which the healthcare specific data platform sits. And when we talk about infrastructure, this boils down to availability, reliability, and scale. So essentially, Google manages its data centers all over the globe. We have locations in multiple places to make sure that there is redundancy and there is always a server that's available in your region. There is compliance attestations, and BAA refers to documentation that we provide to our customers, and third-party attestations like SOC, like HIPAA, like FedRAMP, that provide third-party essentially documentation that we meet the requirements of the regulatory regime within which we operate. We sign BAA with customers because we have the controls to enable them to implement their policy around data security and data privacy. We have transparent approach to pricing through means of calculators, which enable you to plan your budget around cloud consumption. And then there is billing and usage metrics, which enables you to monitor your consumption and adjust accordingly. The data governance layer, which kind of sits on top of that, has to do with maintaining essentially a data governance best practices. So here the idea is that you can very clearly monitor custody chain over specific with a higher level of granularity and monitor this custody chain over the data that you manage within your system. So this includes consent management, this includes provenance management. For example, when you have different versions of the data set, how do you effectively manage these versions? How do you, if you need to investigate, if you need to provide some documentation to a third party, we have, this is kind of, this audit trail is built into the system. The second layer here, marked with number 2, is the data platform. So this is where things become really interesting, and we're becoming increasingly healthcare specific. And what this data platform contains essentially is a set of cloud managed services that understand natively healthcare standard data formats and provide additional services on top of these data formats. What I mean by that is you could use the cloud by essentially storing data in our storage, but then you're not necessarily taking advantage of some of the advanced capabilities around analytics, around machine learning. What we have built in the data platform is a cloud managed solution that speaks native DICOM. We have a solution speaks native FHIR, speaks native HL7 v2. Now, some of you might be familiar with the upcoming ONC CMS legislation that requires providers to provide data to patients about their medical records, specifically around billing. And the format that is prescribed by the legislation is FHIR. So this is definitely a component of the system that we're seeing a lot of uptake, because this enables providers to accelerate that path to being compliant with that new legislation that is about to kick in. So another, besides the data management services that support FHIR, DICOM, and HL7, we have a set of additional services like de-identification. Anyone you talk to in the healthcare space, sooner or later, when you're talking about doing research or even collaborating, de-identifications come to the forefront. How do you do the identification of medical imaging data effectively? How do you extract data not only from the DICOM tags, but also from the pixels, where sometimes the PHI is being burnt in? How do you import and export data from existing on-prem systems or just CDs that are lying around, sometimes large archives? There is a notion of natural language processing services. So how do you essentially process a report, radiology report, and extract incidental findings? Or how do you find inconsistencies between what's written in the report and what's showing up in the image? So we see partners working on solutions that are using our infrastructure around NLP to build these kind of specialized use cases. And then the last piece I want to touch on here is number 3, and this is the analytic platform and the ML platform. So this is really the highest level. I would say this is the reason why customers are interested in this platform, right? Because most of the customers we are talking to, they have this idea that they want to enable building applications on top of the data they have. They either want to develop their own AI, or they want to take advantage of someone who developed this AI. They want to run large-scale analytics to understand reference patterns. They want to understand leakage, patient leakage in their hospital, why patients are coming for pre-op imaging but then are not going through the surgery, because that costs them money. Who are the patients that are likely to be no-show? Maybe I should be double booking my imaging systems. So these are the applications that are much easier to develop once you're building the solution on top of our underlying platform. So with this in mind, I want to kind of touch base on the last piece. I want to share with you how we work with Visage and other partners to develop some of these solutions. I think what makes Visage is really unique in this space is that they have a very strong vision for the medical imaging space, and that we share that vision. And I think that they've been showing by gaining traction in these very advanced large academic medical centers, and showing what's possible when you use this advanced technology, and how do you demonstrate ROI efficiently, and how do you improve efficiency with large systems. So I'm really excited to see what else we can do together. Happy to answer questions later on. Thank you very much, and passing it on to Sean Lambright.
Thanks, Arie. Thanks, Bobby. Great content so far. I really appreciate that. My name is Sean Lambright. I'm one of the global heads with Visage, and I'm going to change the direction of the session a bit to what the ideal cloud PACS platform and the qualities that it should actually have inherently. And if you look across the spectrum of all the qualities that it should have, one theme stands out, and that's simplicity. Simplicity in implementation, simplicity in learning how to use one system, whether you're an administrator, whether you're a tech, or whether you're a clinician. Simplicity in scale, being able to scale resources, compute resources up and down on the fly. Simplicity in support, adding new functionality, so not having to bring your system down or move into some kind of scheduled downtime in order to make updates or upgrades to the system. Simplicity in AI integration, and of course, one that's important to everyone, simplicity in its pricing and the pricing model that's inherent to cloud and SaaS-based systems. Cloud engineered technology, if you think about what it needs to be, it must be highly performant. It must make optimal use of cloud and compute storage. And I think one of the initial hurdles with cloud, or transitioning, as Bobby touched on, legacy systems to the cloud, are the inherent costs. So if you're transitioning hundreds of servers, whether they're bare metal or even virtualized, into the cloud, you're going to incur bigger cloud costs. So the economies must kind of make sense. It needs to be a kind of a sound economic model. But going back to cloud engineered technology, it must be fast. It must be faster, equally as fast as any on-premise system. It must be able to scale to the enterprise. The pricing, the implementation, the way the system works, everything must be more transparent and hassle-free. And if you really think about software as a service today, and you think about how many applications you use on a day-to-day basis, you know, Bobby mentioned streaming music services, maybe like Spotify, all the various streaming TV applications that are out there, media applications that are out there. You just don't think about it. These systems just work, right? When you sign up for a streaming media service, you don't ask them what kind of operating system they run on or how many servers support the system. You just don't, because you know it just works, and whoever is on the other side of the curtain just takes care of it for you. So as we kind of look to the ideal cloud-based PACS platform, these are all qualities that it must have, whether you're eliminating one PACS system at one hospital or multiple legacy PACS systems at multi-regional institutions. It doesn't matter. A single cloud PACS platform or an ideal cloud PACS must have all of these qualities. If you look at the economics quickly, and maybe in the Q&A on Thursday, we can delve a little deeper into this, because I imagine there's going to be a lot of questions in this area. But if you look at a SaaS model, or as Arie described it, a SaaS model, I like that, I'll have to steal that one. You look at two things. You look at the licensing component, and many vendors have already transitioned to subscription-based or operational-based pricing models. But certainly if you're still on-premise, typically there's a large capital upfront expenditure. And in cloud, you're transitioning these fees to kind of a service-based model. So you're not writing one big check up front. You're actually spreading the cost of these fees over the term of the agreement. So now with a operationalized or a subscription-based licensing model and an operationalized model for your compute and storage fees, are able to spread the cost out. And certainly this is much more important today, post-COVID, where we see a lot of capital freezing going on right now, but operational budgets still seem to be largely intact. Cross your fingers. Staffing is another interesting item to discuss. You know, when we engage our customers and we look at legacy PACS systems and we understand why they're actually looking to make a change or maybe considering a cloud-based PACS, all we really hear about are all of the nightmares, the horror stories. It's been described from, you know, as everything from a death by 1,000 cuts to, you know, all the sleepless nights staying up for scheduled updates or unscheduled downtime. And really, if we were able to shift the responsibilities of PACS administrators to not just break fix, but all of the things that they could be focusing on that are productive, that are either revenue-based are intended to improve operations. That's what PACS administrative staff should be doing. They should not be focusing on break fix, perpetually break fix. These are, again, all qualities that an ideal cloud PACS should have. Boxes and wires, so it's kind of a fun comment, but it's really intended to describe servers, infrastructure, storage, security, all of the above. But in order to stay technologically current, certainly from a hardware perspective, one thing you might look at is maybe 3-4 years into an on-premise implementation, you have to refresh that hardware, you have to go out and find out the next new and make sure it works with your vendor's platform, and you don't have to do this anymore, it just goes away with cloud. So as I mentioned earlier with SaaS-based models, you don't need to think about these things. You can shift your focus to other areas that are more important to the organization. Security and reliability, look, I couldn't guess what Google spends per annum on security for their infrastructure, for their data centers, for their cloud environment. But to suggest that any institution, whether you're in healthcare, manufacturing, or finance, it doesn't matter. You know, companies like Google spend significant funds to make sure that they're always at the latest and greatest. Next slide, please. Implementation is a big one. Another aspect of an ideal cloud PACS must be that you can implement quickly. So the days of signing a contract, executing a bill of materials to your VAR of choice for the hardware, and then waiting multiple months for that hardware to be delivered, implemented, racked and stacked, and then finally ready for X vendor to implement or install their software. That process alone, we've seen it take anywhere from 4 months to a year. So literally just sitting on your hands, doing nothing, waiting for hardware to come, be implemented, and go through those very basic processes. So a cloud-based deployment should, by and large, eliminate that process by 90% potentially. So streamlining the implementation process is a huge aspect of an ideal cloud PACS. Whether you're deploying a cloud PACS to a local, a regional, or a national enterprise, it shouldn't matter. The system should be able to scale up or scale down as needed. It doesn't matter anymore if it's an academic institution, community, outpatient, telerad. Certainly the ideal cloud PACS should be able to cut across all components of the market, because really in the end, workflow is generally the same. There are certainly nuances to all of those categories, but in the end, it should be able to scale up, scale down, and just simply provide the functionality that is expected by any of those categories. A single viewer concept, you know, the more we thought about this, really it's so important to have a single GUI, a single user interface that all end users of the system can interact with. So whether you're a diagnostic radiologist, whether you're a tech, whether you're an administrator, if everybody's seeing the same interface and working with the same set of tools, it makes that dissemination of knowledge and an understanding of how to use the system that much better, certainly for initial training and certainly for the ongoing requirements to train maybe additional radiologists, new employees, or with that existing staff, making sure that they're easily able to understand new updates to the system. So really, in the end, not having to relearn a new GUI or multiple GUIs in order to go through your day-to-day workflows. Other things that a cloud PACS should have, certainly enterprise workflow, the ability to kind of massage and provide a seamless enterprise work list across multiple institutions, possibly with multiple HL7 feeds coming in, and certainly long-term medical legal archiving responsibilities. And I think an ideal cloud PACS to add onto the archiving component absolutely should have worked with whichever vendor it's partnered with to ensure that optimal use of cloud-based storage is in fact the case. So all of these things combined lead to kind of forward-looking concepts, but you think about AI and you think about what a platform actually is. And so a cloud PACS should in fact be a platform. It shouldn't be a monolithic closed system that was just smashed into the cloud and hope you hope that it works right. That's, you're planning for failure there. Plan for success. An ideal cloud PACS platform should enable the integration, quick integration, seamless integration of third-party AI. And as we sit here today, there's approximately 50 FDA-cleared algorithms for radiology. In a few years, there may be multiple hundred, if not multiple thousands. So the sustainability of integrations and ensuring that that GUI, that user interface, is seamless to the end user is important, not just for the ideal cloud PACS platform, but certainly for the users of these systems. And of course, any of these systems should be based on standards-based technology, because there are still requirements to integrate to third-party tools such as the reporting platform, the EHR, third-party specialty viewers, etc. Next slide, please. This is my last slide, and we use the term compress and send. And what we're really saying here is pretty much every legacy PACS system creatively compresses medical images in some fashion. And this technology has been around for a while, and every vendor does it a little differently. But in the end, you have to compress data to effectively get it over a network and get it to the end user. And you got to predict where that end user is actually going to be. And if you take that same workflow and you apply it to cloud, it just doesn't make sense. It's one thing to get the data up into the cloud, but at that point, if you have to pull it back down, that defeats the purpose. So an ideal cloud PACS must have the ability to effectively move data from the cloud to the end user. And naturally that would mean something like a server-side rendering platform. So again, not moving just the study, but the entire patient jacket, because there's typically a focus on the current study. But if you think about it, if you're going to provide adequate patient care, you really need the entire patient jacket. And that could mean 5 studies, it could mean 15, it could be 100. So how are you going to move that amount of data, physically compress it, send it to a local workstation for a radiologist to interpret? It's not going to work. It's not going to work. And that's just the entire patient jacket, notwithstanding the ever increasingly larger sizes of data sets. We talked a little bit about being able to spin compute resources up and down at will, but whether you're growing organically or whether you're growing through merger and acquisition, you should be able to very quickly and very effectively spin up compute and storage resources on the fly. You don't have to move mountains, you don't have to implement more servers, you don't have to implement more software. Really, the responsibility shifts to the vendor to take on these things, working with the customer. But these aren't the kind of big, macro events that we generally think about. These should be very seamless and very easy. We kind of call it a cookie cutter approach. All of these things together are really a built-in strategy for growth for any organization. At this point, I'm going to turn it back over to Bobby, and he's going to speak a little bit to one of our last few slides here, and I appreciate everybody's time today.
Hi guys, this is Bobby. So just a little bit of an introduction to the actual deployment process and architecture that Visage uses when we're deploying in the Google Cloud Platform. So with Visage, we recommend redundant network connections so that you've got, for example, both AT&T and Verizon connections to the internet. And each of those would of course be protected via VPN into the cloud so that the data is protected while it's in transit. That also provides you the ability to have redundancy in case one of those goes down. And while they're both operational, you can even have double the effective throughput if necessary to get the data into the cloud. Having the partner peering is the ideal configuration for that. You can even probably, in most cases, utilize your existing internet connection. You may even not have to increase the performance of that. We've often found customers already have enough of an internet performance spec available for their general internet usage that there's enough bandwidth available on that connection to serve their needs, getting the data into the cloud. And then getting the data back out oftentimes depends on where the people are actually accessing it. Certainly during the COVID-19 situation right now, where a lot of radiologists and other primary users of medical imaging are working remotely, it takes a lot of the pressure off of that network at your facilities so that you can allow people to distribute that network demand across the cable modems or other type of network service that they might have for their home offices. We've even got users that are actively working and reading via tethered cell phone connections, since the Visage environment does not require higher performance than what that often offers. Oftentimes even a relatively low speed cable modem is plenty sufficient for all of the different types of radiology imaging that are out there. So with the Visage environment in the cloud, it's fully abstracted from having to manage any of those resources. All of that deployment is done in the native GCP environment on the native GCP servers. and is optimized even to automatically spin up and spin down different services as they are needed for load throughout the day, or as you grow to automatically increase the storage capacity, for example. We're certainly looking forward to an opportunity to talk with you about how this would work in your exact configuration, and how we can optimize your use of medical images as delivered from a cloud environment. And on that, we'd certainly like to offer any Q&A. I know we have a scheduled opportunity for that later this week as part of the Virtual SIM 2020, and we're looking forward to interacting with you at that time. Thank you.
Well, thank you, everybody. Thanks, Bobby. Just wanted to summarize real briefly before we close today. So we learned about how the cloud has really surrounded us with capability in really crossing multiple vertical markets and touching us from consumer perspectives in all aspects of our lives. Today, we see that happening in healthcare and imaging as well. We're all capturing healthcare content and getting electronic health record information on our mobile devices as well. And frequently, that information is fueled by the cloud. So why hasn't the cloud come to the PACS world to the extent that everyone has anticipated for the last several years? As our speakers today shared with us, legacy PACS systems were really never intended for the challenging architectures of the cloud. If you think about it, legacy PACS was developed last century. That's going back 25, 30 years. Those architectures couldn't even envision mobile devices, let alone cloud-based PACS deployments. So when you're trying to put a square peg in a round hole, you're really going to be doomed to failure. The ideal PACS platform, as Sean took us through, really helps elevate the level of capability to match the expectations of end users across the healthcare spectrum for what an ideal PACS system needs to be. It's not a future, it's happening today. And we look forward to those conversations with you. Available today are cloud engineered enterprise imaging platforms that were designed for the cloud. They, at a foundational level, eliminate the hassle of the legacy PACS environments that many of you are struggling with today, keeping those systems alive, planning for your next forklift upgrade, etc. The cloud needs to be transparent and economical for all institutions. And luckily, it's not on the horizon, it's here, allowing you to have fast, clinically capable, and highly scalable PACS that can meet your local needs, your regional demands, or even national healthcare enterprises. With that, I want to thank my speakers for their outstanding content today, and we look forward to answering any of your questions during the Q&A. Thank you very much.